Okay, the next problem we're going to look at is a center of mass or area under the curve problem. So it's really about center of mass, and we're going to have to find the area under the curve. So just a reminder of integrals. So we have a plate with some density, and it's bounded by these curves. We want to find the center of the mass. So my first step for doing this is always going to be draw the picture. This is my x and my y. So y is equal to x plus 4, so when x is equal to 0, y is equal to 4. When y is equal to 0, x is equal to minus 4, so that's this line. Ooh. So y is equal to x plus 4. Y is equal to minus x plus 4, so it's just going to be the opposite of that. And it's going to intersect here at the point y is equal to 4. And then my last one is x squared over 2, and it's going to do something like this. So the region I'm interested in is this stuff. Okay, so what we need to do really is find these points. So, and the reason we're going to do that is because we're going to have to integrate something. So let's find these points. We have x plus 4 is equal to x squared over 2, which implies that if we just multiply over the 2 and then subtract the left-hand side of x squared minus 2x minus 8 is equal to 0. And we can factor this, so we have x minus 4, x plus 2 is equal to 0. Well, and it's obvious from this picture we want x is equal to minus 2 is the thing we're interested in. Okay. By symmetry, you could just say this other one has to be x equals 2, but let's check that. The other point is minus x plus 4 is equal to x squared over 2, which in turn, similarly, get x squared. Now we have plus 2x minus 8 is equal to 0, or x plus 4 x minus 2 is equal to 0, and well, this has to be the positive one, so we want x equals 2 is our other bound. Okay. Now, to find center of mass, the formulae for the center of mass are x bar, y bar, that's what we want, is equal to my over m, mx over m. Be careful, because x here has a y here, the y has an x here, so be careful about that. Where, I guess we'll explain in a minute what my and mx and m are. So first let's find m. We know we're going to have to need m in all these formulas. So m is the mass. So m is going to be, well, it's density times area. To find the area, we're going to have to integrate this yellow region, right? So we're going to have to do something like this. Everything enclosed by that. Okay, how are we going to do that? Well, I'm going to do this by doing a little trick called using symmetry. So I'm going to, instead of going all the way from minus 2 to 2, I'm just going to go from 0 to 2 and then multiply by 2, because the area is equal on either side. So I'm going to say this is the integral. Whoops, we have rho times 2. I'm going to say integral from 0 to 2. And then I have the upper curve minus the lower curve. Now in this case, my upper curve is minus x plus 4, and my lower curve is x squared over 2. So I have minus x plus 4 minus x squared over 2 So I have 2 rho minus x squared over 2 plus 4x minus x cubed over 6 from 0 to 2. And this gives me 2 rho minus 4 over 2 plus 8 minus 8 over 6. And if you work this out, you end up getting 28 over 3 rho. So this is our mass. That's the first thing we want to notice. Okay, you can go ahead and check on your own that if you wanted to not use symmetry, you'd have to use, so I'll leave this as a check for you. Mass is equal to, we have rho integral 0 to 2 minus x plus 4 minus x squared over 2 dx. That's what we just did. But then you'd also have to do plus rho from minus 2 to 0, x plus 4 minus x squared over 2 dx. So check this, you'll end up getting the same thing. Okay, so now that we have mass, we need to find my and mx. So be careful, these depend on rho. My and mx will as well. Okay, so first we're going to find my. Well, the equation for my, if we have some curve f of x here, some other curve g of x here, and this is our region, we have my is equal to rho. If this is a and this is b, we have integral a to b x f of x minus g of x dx. So here we can see we're going to have to do something because we have two different regions. So for us, it's going to be rho. First we're going to do from minus 2 to 0, x, and then my upper integral on this bound is going to be x plus 4, right? That's this one. My lower one's going to be x squared over 2. So if x plus 4 minus x squared over 2 dx. And then I'm also going to have to do the integral from 0 to 2, x. Now that's going to be minus x plus 4 minus x squared over 2 dx. Right? Okay. So my is equal to rho. Now let's integrate this term by term. Well, I'm going to multiply through by the x. So we're going to have the integral from minus 2 to 0 of x squared plus 4x minus x cubed over 2 dx plus integral 0 to 2 minus x squared plus 4x minus x cubed over 2 dx is equal to rho. And now I'm going to plug this in. I get x cubed over 3 plus 2x squared minus x to the 4th over 8. And this one goes from minus 2 to 0. Plus rho. And this one's minus x cubed over 3 plus 2x squared minus x to the 4th over 8 from 0 to 2 is equal to rho. Everything at the top is 0, so what we're going to do is just plug in minus 2, and we're going to have minus everything, because we have 0 minus all this stuff, and we have minus 2 to the third is minus 8 over 2, plus minus 2 squared is 4, so plus 8, minus 2 to the fourth is 16, minus 16 over 8, and then we have plus rho, and then we have minus 8 over 3. Oops, I just noticed this should be a 3. So minus 8 over 3 plus 8 minus 16 over 8. Okay, so what does this look like? Let's put it all together. We have rho, and we have 8 over 3 minus 8 plus 16 over 8 from the first stuff. And then we have minus 8 over 3 plus 8 minus 16 over 8. Well, if you notice, this all just cancels. This cancels this cancels this, and this cancels this. So we have this is equal to 0. Now, I tricked you a little bit because we could have just read that off, right? If you understand what center of mass is, we know exactly what that is. So we were trying to find my. So my corresponds to the x center of mass. The x center of mass is the place in the x direction where you can balance this object. So that's obviously going to be here because we have as much mass on the right as we have on the left. So for x less than 0 and x greater than 0. So the center of mass, so that implies the y moment has to be equal to 0. Okay, so it's good that it worked out, but you don't have to do that calculation. You could just say by symmetry the y moment's equal to 0. Okay, so what we need to find is the x moment now. This one's not necessarily going to be the same thing. We don't have the same sort of symmetry. Because if you look at the picture, here, there's not as much y on the top as there is in the bottom, or vice versa. I can't tell. But it's not symmetric. So mx is given by rho. So in the general case, it's given by rho times a to b, or integral a to b, 1/2 f of x squared minus g of x squared dx. So for our case, we're going to have to split it up, right? We're going to go minus 2 to 0, 1/2, and now our f of x is x plus 4 squared minus x squared over 2 squared. That's just the first part, and the second part is going to be 0 to 2, 1/2 minus x plus 4 squared minus x squared over 2 squared. I should have a dx here and a dx here, and then that's it. Okay. So what does this work out to? Well, we're just going to have to do it. Oop. Yeah, this is minus 2 to 0. And I'm just going to expand everything out here. So I have x squared plus 8x plus 16 minus x to the 4th over 4 dx plus, oh, I've brought out a 2. I have rho over 2 for each of these. 0. 0 to 2, and I have x squared minus 8x in this one, plus 16 minus x to the 4th over 4 dx. Okay, so this is rho over 2. And then I have, well, let's see, I'm going to have x cubed over 3 plus, this is going to be 4x squared plus 16x minus x to the 5th over 20. This is going to be from minus 2 to 0. I'm going to have plus x cubed over 3 minus 4x squared plus 16x minus x to the 5th over 20. This is going to be from 0 to 2. And then we just have to plug in. So everything for the 0 term is going to be 0 here, right? Because they have an x and x and x and x. So what we're going to get is minus 2 to the 3rd is again minus 8 over 3 plus 4 times 4 is 16 minus 16 times 2 is 32 minus, well, negative 2 to the 5th is going to be positive 32, or sorry, negative 32 over 20. And that's this one, and then on the other term we're just going to have 8 over 3 minus 16 plus 32 minus 32 over 20. And if you see, a lot of these terms are the same. So we have rho over 2, and we have, so let's bring this inside. This becomes a minus sign, this becomes a plus, this becomes a minus sign. So we have 2 times 8 over 3. So we have 16 over 3 is this first term. And then we have minus 16 plus minus 16 is minus 32. We have plus 32 is plus 64. Minus 32 over 20 minus 32 over 20 is minus 32 over 10. And if you work this out, you get rho over 2 times 512 over 15, and this becomes 256 after you divide by 2. So what we have is that x bar, y bar is equal to 0, mx over m. We already found 0 for x bar, and we have 0, this is rho times, well, 256 over 15, and what do we find our mass to be? Well, our mass is 28 over 3 rho times 28 over 3. So this is equal to 0, and we have 256 over 15 times 3 over 28. And you could simplify it more, or you can just leave it like this. That's okay.